Hi, and welcome to the first of four short videos that describe two optional projects in JavaScript that you can do in the class. Now, these are purely optional. You don't have to do them, but you might find them interesting depending on your particular interests. They're both based on the same data. I'm going to talk in this first video about where the data come from and what they look like. In the second video, I'll talk a little bit about how using P5.js, which is a JavaScript framework or library, we can import these data to a web application and use them. And then in the last two videos, I'll talk about the specific projects, one of which visualizes the data using a graph, an interesting sort of scrolling graph, and the other one of which actually plays the data as audio, which if you have a bent for sound and or music, you might find interesting. So that's what's coming up. To start with, this project is going to analyze some data I collected from my front yard about weather. Now, you can get weather from the National Weather Service and from many websites. However, you can also put inexpensive instruments out in your front yard or backyard and collect data from them. You've probably seen sensors like this. This one is designed to mount outdoors, and it sends the temperature and the humidity, I believe, to an indoor station like this one, which receives and displays the results. The transmission of data from this one to this one is over a radio frequency, usually 433 megahertz. Not that that matters, but that's the key to capturing these data. So if you don't want to just watch the temperature and humidity here, but you actually want to record the temperature and humidity as they change throughout the day, moment to moment, you can use software, in this case running on a Linux computer, but it would also run on Windows, to capture the data stream between this device and the receiver and decode it and record it in the form of comma separated value data, which we can actually then use to track and visualize the temperature, humidity, wind, and rain changes over time. So let me show you really quick how this works. I'm going to share my screen and show you the where the data come in. So this is how the data come in. This is the green screen you see with the scrolling data, the one that says all the names in red of the various devices. This is actually receiving data from one of these sensors and recording it on an SD card by means of a Raspberry Pi computer. And you'll see, if you look, the names of the various sensors. Accurite Tower, I think I have an Accurite sensor somewhere, an Oregon Scientific sensor, another common brand you might see at Home Depot or Lowe's, and probably some other sensors that belong to the neighbors, because after all, as radio, it crosses boundaries between properties. I can actually read the temperature in my neighbor's yard. In addition to displaying the data this way, this program, which is called RTL433, will save the data to a comma separated value CSV file. Let's take a look at that file. So I have captured data over several months, since like November of last year, I think up and through February of this year. So it's a sample of data, and I've captured the humidity, the temperature, the wind gusts, and the rainfall amounts. And if we look at that data, so I'm going to share my screen again and show you the what that looks like. If we were to open up the CSV file that is produced from the program on the Raspberry Pi, what you would see is data like this. Now we're looking at this in Visual Studio Code, and Visual Studio Code has a nice add-on that will color code some of the columns for you, but you can see pretty clearly there's a header column at the beginning. That's kind of important because that names the columns. That way you don't have to remember which column number is which, 0, 1, 2, 3. All you really have to do is know, I want the date and time. I want the temperature, I want the humidity, or I want the rain amount. There's a lot of data here. If we scroll all the way to the bottom, there's like 6,000 lines or something. So sampling like once a minute for months gets you a lot of data. If you were to open this data in a spreadsheet, which you certainly can do, it would look like this. Let me share that one with you. If I can find it. Okay, I can't find it, but that's all right. You can imagine what that looks like, right? You've seen it in a spreadsheet. So, um, okay. So now we've got the data, we've got it captured in a CSV file. There's a couple of things we can do with it. And that's what the subsequent projects talk about. They talk about either visualizing the data by making a scrolling graph that shows you not all the data at once, but shows you a day or two's data at a time and scrolls along in almost like a simulation of time moving. And you can see the temperature and the humidity and the rainfall change and various events occur. And I'll give you a partial program there and you can complete it. There's another program, which is much more open-ended project that I would ask you to consider. And that's a program that basically makes sounds, plays audio. We won't say music, we'll say audio, that represents the temperature and humidity over time. And it sounds pretty weird. You'll get to see it when we run it. And if you have an inclination with various audio, if you experiment, let's say, with various audio systems, or you like music, you might find an interesting way to use this data in some. It wouldn't be a visualization; it would be an audibleization, I guess. And I think that could be fun. So that's what's coming up in the next video.